Here is a simplified illustration showing the integrated system of the three mechanisms we have observed, namely electric motor, transmission system, and magnetic switch. Let's look at the connections. The positive terminal of the battery is connected to terminal 30 and the ignition switch. Terminal C is connected to the field coils and armature coils grounded to the engine and ultimately connected to the negative terminal of the battery. Thick cable is used for these connections to allow strong current to flow. Terminal 50 is connected to the positive terminal of the battery via the starter switch. Using this illustration, let's look at the operation of the starter motor from starter switch turn on to turn off. When the starter switch is turned on, electrical current flows to the pull-in and hold-in coils, then to the field coils and armature coils, and ultimately to ground. However, since the electrical resistance at the field and armature coils is very low while battery voltage is applied to the pull-in and hold-in coils, the magnetic fields generated by the coils pull the plunger toward the right. Via the drive lever, which is linked to the plunger. This movement causes the starter clutch to move toward the left along the screw splines of the armature while rotating. And when the pinion gear meshes completely with the ring gear, the main contacts are closed. When the main contacts are closed by the contact plate, the field and armature coils are connected directly with the battery. This causes stronger current to pass through the starter motor, rotating the armature with greater torque. Since the main contacts are closed at this time, the voltage levels at terminals C and 50 are equal, so the pull-in coil no longer pulls the plunger, which is therefore held in position only by the magnetic force exerted by the hold-in coil. When the starting switch is turned off after engine start, the main contacts remain closed, as shown here. Since electrical current flows to the pull-in coil from the main contacts, the coil generates a magnetic force opposite in direction to that generated by the hold-in coil. The magnetic fields generated by these two coils therefore cancel each other out. The plunger is then pulled backward by the return spring, opening the main contacts. At the same time, the pinion gear is disengaged from the ring gear and returned to its original position. The conventional starter motor incorporates an armature brake mechanism, which immediately stops the armature when the engine fails to start. This mechanism is constructed like this. Lock plates mounted at the end of the armature shaft support the brake springs. Let's see how the mechanism operates. While the starter motor is in operation, the entire armature is pushed slightly left by the drive lever. When the starter switch is turned off, the brake spring returns the entire armature to its original position. Since the armature is then pulled against the brake contact surface of the brush holders, it immediately stops turning. So far, we've observed a conventional type starter motor. However, reduction-type starter motors like this one have been used increasingly in recent years. Operation of the reduction-type starter motor is essentially the same as that of the conventional type. While looking at the actual operation of the reduction-type starter motor, we'll examine its construction features. When the starting switch is turned on, the magnetic fields generated by the pull-in and hold-in coils pull the plunger. This is the same as with the conventional type. Since the pinion gear is directly connected to the plunger, however, the plunger directly pushes the pinion gear toward the ring gear. When the pinion gear meshes completely with the ring gear, the main contacts are closed. At this point, the field and armature coils are directly connected to the battery, as in the conventional type. This connection allows strong electrical current to pass through the starter motor, causing the armature to rotate with great torque. The distinctive feature of the reduction-type starter motor is its use of a high-speed motor. The motor speed is then reduced by 3 gears to generate greater torque, which powerfully rotates the pinion gear. Next, we'll examine the planetary-type starter motor. Compared with the conventional and reduction types, this type of starter motor is more compact and lighter. The operation of the planetary-type starter motor is essentially the same as that of the conventional and reduction types. When the starting switch is turned on, the magnetic fields generated by the pull-in and hold-in coils pull the plunger. This is the same as with the conventional and reduction types. Also, the construction and operation of the pinion gear and starter clutch of the planetary type are the same as those of the conventional type. The distinctive feature of this type of starter motor is the mechanism that transmits the armature rotation to the pinion gear. The armature rotation is transmitted to the sun gear, planetary gears, and ultimately the pinion gear via the planetary gear shaft. At this point, rotation speed has been reduced to 1/5 the original level, while torque has been increased. This mechanism is also applied to automatic transmission vehicles.